Hello everyone. Tonight we're going to be talking about soils and amendments to support our learning of site assessments and planning for different types of plants that go in the landscape. So we want to gather site data to ensure the success of the plants we've selected. And just as a quick review, we import a lot of water to our region. So you can see this is a typical curve, and it shows that most people are overwatering plants in the summer, and that extra water we could save money and be more sustainable if we're kind of monitoring our water. And one of the ways that we ensure that we're watering appropriately is to understand our site soil and create a healthy, sustainable soil. So again, we talked about in the past, about 70% of a residential water bill is used outdoors. And we talked about water conservation being a factor of efficient irrigation systems and very, plant water use demands. So again, we looked at different types of irrigation equipment and how efficient they are or not efficient they are, and different types of plant material that we are fortunate to select from in our region. So again, a review of the very low water use plant material, kind of our low water use plant material, moderate water plant material, and high water use plant material, which are falling out of favor based on the restrictions that the state has imposed in regards to water budgets. So again, we live in a Mediterranean climate that is characterized by our rain over a short period of time, followed by long dry periods. And so the Mediterranean region climate plants have different types of adaptations to survive those long periods without drought. They might develop succulent leaves or silvery leaves or very tiny leaves. They might have leathery or waxy leaves. They might go drought deciduous, which means they turn kind of brown and crispy. They may perform solar tracking as water conservation strategies. So one of the ways we research to determine what types of plants will fit where and how much water they need is our different climate zones around the region. So traditionally, most of the landscapes across the country use the USDA plant hardiness zone. And this works well in other parts of the country, but in our region, it can be problematic because it's based on low temperatures. And what happens is if you look at places like Santa Barbara, El Centro, and Outside Needles, you will see that they all have the same USDA zone, but yet have very different climates and grow different plant types. So instead, the standard for our region is to use the Sunset Western zones. Most nurseries will list both types of water of climate zones, but this is kind of the standard for our region. And you can see that there's 24 plus different regions throughout the West, different zones throughout the West, and these are really starting to factor in the evapotranspiration rate and aspect and exposure, and if they're in mountains and altitude, coastal influence really are what are used to drive these more refined zones. So maybe you can pick out where you live in the region and see what your zone is. In Chula Vista, we are in zone 24, so we have a coastal influence. So again, here's that ETO map we saw in an earlier lecture. This is tracking the amount of water that a lawn would need to stay healthy and just the evapotranspiration rate. And you can see that that overlies pretty well with those sunset garden zones. So again, we talked about We don't have a lot of average rainfall. We average about 10 inches a year, so the remaining water needs to be imported from far away. So we want to focus on soil to manage our water on site and also grow healthy plants. So our soil texture, that's the mineral component of our soil, determines how water moves through the soil. It's going to drive our irrigation scheduling, and soil texture can vary greatly throughout the region, sometimes even on the same property. About 70% of the soil textures in San Diego County are sandy loams or sandy clay loams, and those are relatively good for growing plants. So in 1930s, our country had the largest man-made ecological disaster in the United States. This was a series of droughts lasting 10 years, combined from practices like over-tilling and not planting cover crops, caused the topsoil to blow away and contributed to decimating the national economy during the Great Depression. So this affects 100 million acres of farmland, mainly centered in Texas and Oklahoma. And I will post a little clip about this disaster in the campus so you can link to it. So when we look at sustainable soil, we really look at three components: mineral, organic, and pore space. So we're going to focus first on the mineral. That's the actual bits of weathered rock. So we call these bits of weathered rock soil separates. Sand is our largest, silt is our next, is our medium sized, and then, sand is our largest, silt is medium sized, and clay is our smallest. And so our soil is based on different combinations of sand, silt, and clay. So for your homework tonight, or this next week, or lab, whatever you want to call it, you're going to be doing soil texture tests a couple different ways. One way is to do a mason jar test, where you're going to fill a jar halfway full with water and halfway filled with soil and shake it and let it settle down and read the percentage of sand, silt, and clay in the jar. And you can use this soil USD soil texture calculator to calculate those percentages. And what you would do is, say if you were on the sand layer and you had maybe 40% sand, you would go along the bottom of the pyramid to the 40, and you could see there's kind of a diagonal line going up. And then maybe we had 40% silt. So you would go along the silt axis of the triangle to 40%, and those two lines are going to intersect along with the 20% of clay, and you would see that you fall right in the loam category. So soil influences everything related to water. That is our holding capacity, water movement, and water retention, and that all factors into our irrigation scheduling. So sandy soils are fast draining. They don't hold water up where the plants need it very well. They don't hold nutrients up where the plants need it well, and it is a very workable soil. Silt is a medium draining soil. It does a pretty good job of holding water up where the plants are. It does a pretty good job of holding nutrients where the plants are. Clay is slow draining. Once it gets wet, it holds water really well. It takes a long time to dry out. It also holds nutrients really well. In fact, it holds them so well, the plants can't usually get the water and nutrients away from the clay. It's so highly charged. So we can look for internet-based tools to determine our soil texture. There are soil surveys available online for your area. You can review your property soil sample. We'll look at another way to do soil sampling as a ribbon test and actually perform a ribbon test. So again, here's that USDA soil triangle. Here is what a soil survey looks like. You could actually log on to this site and pull up your area. This is a tricky platform to use, but with a bit of finagling, it is available information. And then we can pull a soil sample to use either in our mason jar or our ribbon test. So if you had a soil probe, you could push that probe into the soil and pull up a core. You could use that to identify the existing root depth, or you can pull a number of cores around the site to create your robust soil sample. So you're going to dig, most of us don't have a soil probe, it's a pretty expensive tool. So you're going to brush aside any mulch or organic matter that's on the surface, and you're going to dig down at least 6 inches down and take a sample from the side of the hole. Think of slicing a sliver of a cake off the side. For the ribbon test, you're going to wet that sample down. It doesn't want to be overly saturated, but just wet enough that it starts to stick together well. And you're going to try and roll it into the ball. And if you can't form a ball, then that means you have sandy or sandy loam soil. If you're able to form a ball, you then move into trying to extrude a ribbon, and depending on how long of a ribbon you're able to extrude tells you how much clay is in the soil. And this exercise is called a Thien test. So you can see this flow chart. You start at the top, you're going to add water, and you're going to try and form a ball. And if it doesn't form a ball, it's in the sand category. And if you can form a ball and you start to kind of push it through and there's no ribbon forming, we would say that's loamy sand. Or sometimes I like to, if we have a ball, I like to poke it, and if it just falls apart right away, that's loamy sand. If we're able to kind of extrude a ribbon, depending on how long that ribbon is going to tell us whether we have a loam soil that's more towards a sandy, silty loam, or more of a clay loam, or clay. So you're gonna have this assignment to get to know soil in your location. If you live like in an apartment and there's no open landscape around you and you'd rather do it at a parent's house or a boyfriend or a girlfriend's house, that's just fine. Second component of a sustainable soil is organic matter. So we want a healthy, sustainable soil so that it supports the soil food web, and you have beneficial organisms in the soil. We want to encourage those organisms with proper moisture, organic matter, balancing the pH, and having some pore space to provide oxygen. So these are the components of a sustainable soil. We have bacteria. Now weeds, a lot of people think are undesirable, but they do perform a function in that they grow and shed a lot of organic matter quickly. So they're actually adding to a depleted soil. So if we want to shortcut weeds, then we could add organic matter and it would be less attractive for weeds to grow. We also have nematodes, fungi, worms, and then of course plants. That is the ultimate, healthy plants to respond from having healthy soil. So pore space is something that people forget about, but it is an important component to a healthy, sustainable soil. So we want aggregation in our soil. What that does is it creates little voids where the roots of the plants can get air or water to grow healthy. So you can see in this little cross section of a root, and that this root has the availability to grab water from this glaze of water around these aggregates, or get air from this pocket void that's in the soil. So urban soil tends to be compacted, and it lacks this, it's lower in organic matter, and it lacks this void space of air. You can see how much, about half the air is in the soil in a compacted urban soil than in like a forest soil. So that is a challenge in our region, is to get our soil uncompacted. So we want to reduce compaction and increase our plant success. And reduced compaction is going to allow better water infiltration, better soil aeration, better root penetration, and therefore better plant success. So here's a study with corn plants. You can see the low compaction soil. Roots are growing all the way to the bottom of the test tube. Medium compacted, they're about halfway down the test tube, but you start to see some stunted growth. And then in the high compaction, you see this little tiny stunted plant. So urban soils, we tend to have a lot of compaction, a lot of times due to our past construction practices. This is an example of an actual project site down below post-construction, and you can see how compacted that soil is, and the plant material did not take the first time. So the way that soil was remediated was by rototilling it in areas that were away from trees, adding a compost into it to loosen up the soil, and this is what it looked like about a year later. So compaction starts with our processes on the soil, and mulch and organic matter are how we remediate compaction. So we want water to infiltrate and percolate into our soil, and soil texture and compaction are key components of letting them do that. Sandy soils generally percolate water quickly. Clayey soils generally percolate very slow. You can also have geological formations that interfere with percolation. A lot of our coastal communities have ancient fossil seabeds that harden up almost like concrete, and they prevent water from infiltrating. So we say less than 1 inch is slow drainage, and we add organics, possibly gypsum, and select tolerant plants to make that a more sustainable situation. If we're in the 1 to 3 inch range, this is really the ideal range. We don't have to do much remediation. More than 4 inches, we'd say fast draining soil, and we'd want to add organics and select tolerant plants. So if you want to take the extra step of doing a field percolation test, you would dig a 12 inch by 12 inch by 12 inch hole, fill the hole with water to saturate the soil, and let it drain once. That may be overnight. You're going to refill the hole with water, measure the depth of the water, and then measure every hour how much the water has dropped. And it's nice if you can come back and do this a few times and then average out how many inches per hour that your soil is infiltrating. So we can also send soil to a lab for testing and recommendations. Professional soil testing should be performed by an independent lab and not as a free vendor service. Soil can be taken as an aggregate sample, so you just take little pieces of samples from many different parts in the landscape and then put it in one bag. Or if we know we have a site issue, we might take soil samples from different locations on the site. Generally, soil testing costs between $100 and $150. It's actually gone up a bit since I wrote this slide. I would say plan for about $200. And you can get specialized testing if soil contaminants are expected. So we talked about how to use a soil probe and how to take a sample. So here's an example of what you would send into a soil lab. I usually select this complete testing for new planting. That's where you need a 1 quart bag filled with soil, so 3 to 4 cups for that full lab test. And common horticultural tests for these labs include soil testing. You could have your water tested, and you can have your compost tested. So here's an example soil test. This is actually called Waypoint Analytical, this particular lab, but you can see that in this example, everything was either low or in the adequate range, sufficient range. I don't have anything that's high in this range. So pretty good soil. It does give you a texture, so you can see we've got sand. If I go to the pH, it's at 6.9. That's a nice balanced pH. You can look at some of the salinity over in here. That's in good shape. And then you can look at all these little micronutrients and see if it's low in anything. So when we amend our soil, we're going to amend elements that may be missing and adjust the soil chemistry to release undesirable elements. So common horticultural soil amendments for our region include gypsum, and that can help release salt buildup and help bring something that is in the alkaline range, so maybe over 7. Usually if you see a pH of 8 or so, we want to bring that down to about 7. We could add sulfur if we have soil from a pocket of our region that is actually high in acidity, and that will help raise the pH towards that 7, which is the goal. NPK is nitrogen, phosphorus, and potassium. These are some of the main nutrients that plants use, and they can be depleted in the soil pretty rapidly. So when you look at most fertilizers, they have numbers like 5, 10, 15, or 15, 15, 15. That's the ratio of nitrogen, phosphorus, and potassium in the soil sample. And then compost provides a lot of micronutrients and natural fertilizers to support that healthy soil food web. A good quality compost is going to be finely screened, should be 90 days mature to ensure weeds and pathogens are killed. If you're going to grow edible plants, you want to avoid compost made with biosolids, which is human waste, and OMRI certified is a good measure of quality. So for remediating compaction, we're going to add organic matter. We're going to work that into the soil either as part of our backfill or maybe even rototilling the site before new planting and build that health of the soil food web. So adding organic matter is going to take a problematic soil and move it into a healthy, sustainable soil. So when we add organic matter, if we're working with natives, we might add 15%. That would be true for also those very arid climate succulents too. But if we have a more traditional horticultural species, we might add 30% of the soil volume as a compost amendment. And this is available in bags or bulk. Mulch. We like to have a compost mulch or a blended mulch. Those tend to break down and feed the soil, and we'll need to replenish those about every year or 2. Wood mulch will eventually break down, but it takes maybe 2 to 3 years to break down. And so a lot of times it can actually tie up some of the nitrogen in the decomposition process. Eventually it'll get all released back to the soil, but wood mulch is not the best option if we're trying to move towards a sustainable soil. It does work really well for trails and walking paths and things where you don't want the wood mulch to break down and feed the soil. So we're going to apply a composted mulch after planting, usually about a 3-inch layer on top of the soil, and then we're going to pull it back away from the plants to allow that crown to have lots of room and not have excessive moisture right where the stem meets the ground. And then we're going to replenish as this amendment, this mulch thins out and has been broken down and worked its way into the soil. So sustainable soil, we're going to prevent compaction, improve drainage. We're going to work with nature, not against it, and add organic matter to feed the soil food web in our region. All right, and that is it for tonight.